turn the page over, and what we're going to look at is quantum numbers. Y'all, there's 4 quantum numbers. These are solutions to Schrodinger's equation, what we just talked about, that fly in the bottle, that knowing where the electron is. The quantum numbers tell us about the electron. Where is it located? Is it close to the nucleus? Is it far from the nucleus? What's the shape of the area that I can find that electron in? Is it in a circle? Is it in a, like this dumbbell shape? Is it at this clover leaf shape, etc.? That's what the quantum numbers are telling us. So, the first quantum number, you see there on your sheet, it's called the principal quantum number. And the principal quantum number is given the symbol N. And I tell you on your sheet that N can be anything from 1 to infinity. It's got to be a whole number, though. So it can be 1, 2, 3, 4, 5, 6, 7, 8, etc., etc., etc. N tells us about the size of the atom. That's what B tells you. And it makes sense that the larger the N, the larger the atom. And what I've got drawn there on your sheet, y'all see that little dot? Well, that dot is the nucleus. And if you were to draw that first orbit around the nucleus, that would be where N equals 1. And then if you were to draw another orbit around the nucleus, that would be N equals 2, another one 3, etc., etc. You could go out to infinity drawing those orbits. N is on the periodic table. When I say N, y'all know I'm talking about principal quantum number. Y'all see the period numbers down the left side of the periodic table, the 1, 2, 3, 4, 5, 6, 7? That is N. So theoretically, N can go to infinity, right? But our periodic table only goes up to an N equals 7 at this point. But that's where your N is. Now, let's move on to the second quantum number. The second one is called the angular momentum quantum number. And the symbol for this one is L. It's a cursive L. That's what I tried to type there on your sheet. It looks like it's L. L can be anything from 0 up to N minus 1. So, y'all, the value of the second quantum number, it depends on the principal quantum number. For example, if N is 1, then L can only be 0, because it can be 0 up to N minus 1. If N is equal to 2, then L could be 0 or 1. If N is 3, then what could L be? 0, 1, or 2. You hit every whole number, okay? If N is 4, then what could L be? 0, 1, 2, or 3. I'm going to run out of room. If N is 10, then L can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But we see the periodic table only goes up to N as 7, so we're probably not going to have anything beyond that. You won't. Okay? What does the angular momentum quantum number tell us? Well, y'all, it tells us the shape. I tell you on your sheet there that the angular momentum quantum number tells you the shape. When we put that fly in the room, and I said, guys, where are we most likely to find that fly? If we look at an aerial view of the room, y'all knew that it was somewhere in that circular shape, right? So that's what L is telling us. In what kind of shape is that electron moving around in? Depending on the value of L, whether it's 0, 1, 2, 3, there's corresponding letters. And your sheet has that. It says that if L is equal to 0, the letter that corresponds to that is S. S is a spherical shape. If you flip in your books to page 236, it shows you the different shapes that are associated with this. And a sphere, it's actually there on page 236. It's just splitting that sphere into one part of it. If L is equal to 1, that corresponds to a P shape. The P's are in the middle of 237. It kind of looks like a dumbbell. Do y'all see that? A figure 8 or a dumbbell. Those are, you'll hear me say, and most of the time we call that a dumbbell shape. If L is equal to 2, that corresponds to a D letter. And at the bottom of 237, those are the D orbitals. They're called orbitals. And we refer to those as cloverleaf. Does that look like a cloverleaf to y'all at the bottom? Except for that one that's kind of crazy. It's like a cloverleaf. It's a dumbbell with a donut in the middle. So it's a little different. But typically you've got those cloverleaf shapes. And then if L is equal to 3, those are referred to as an F orbital. And those aren't in your book, so we don't have to worry about what those shapes are. So from there, it just picks up with the alphabet. But guys, for what we're doing in here, and the only ones the periodic table has, I'll show you later, L can be 0, 1, 2, or 3. Okay, we don't go any higher than that on the periodic table right now, so you guys don't have to worry about going beyond that.
So what is F?
Okay, let's look at the third quantum number. The third one is called the magnetic quantum number. And the symbol for the magnetic quantum number, y'all, is M with a little L subscript, if you will. And A on your sheet says that it can have a value from L to minus L. That is an L on your sheet, not a 1. It goes from L to minus L, including 0. And then B says it describes the orientation of the orbital in space. So, what have we done so far? Well, you have to know what the principle is, number 1. Once you know what that is, you can use that to determine the angular momentum, right? Because these zeros, 1, 0, 1, 2, etc., depended on that. Now, in order to know the magnetic quantum number, that depends on the angular. So you've got to know this one to get this one. Let me show you how these correspond to the L. If L is 0, then M sub L is 0. Because it can only be L, which is 0, to negative L, including 0. And there is no positive and negative 0. It's just plain old 0. So in this next column, if I told you L is 0, then M sub L can only be 0. But if L is 1, then M sub L can be negative 1, 0, or positive 1, because it's negative L to positive L, including 0. So over here, if if L is 0, the only possibility is 0. If L is 1, then this can still be negative 1, 0, or plus 1. If L is 2, then that would correspond to negative 2, negative 1, 0, plus 1, or plus 2. Does that make a little bit of sense?
Really short number lines.
Huh?
Like really short number lines.
Yeah. Yeah. Like short number, always hitting just whole numbers. Now, what we've done here with all these numbers, I know I've got y'all flipping around a lot in your book, but unfortunately it's just everywhere, the way I cover it. Page 234 in your book is a table that summarizes all these numbers that we have here. So, y'all, once you have solved for the quantum numbers, the N, the L, and the M sub L, and the fourth one, which we haven't talked about yet, the solutions for them are always the same. And that's what we're looking at. We are looking at solutions to Schrodinger's equation. Once it's solved once, it's always that. That table at the top of 234 is a table just like this one we're creating here. It's always that. But that might be a lot to remember, so if you can just understand how we get from here to here to here to here, maybe that'll help you out. Now, where do all these numbers go into the periodic table? Because I pointed out to some of you who've had chemistry before, 1s2, 2s2, 2p6, that's where we're going. I'm going to have you flip again in your book to page 246. I wish I had that figure to pull in. I should have looked it up ahead of time. I don't, so I'm sorry. I have to draw something like that. Do y'all see page 246 shows a diagram of the periodic table, and it's a little bit different from mine because they have all that yellow stuff inserted. Do y'all see on there the yellow? I'm not showing that here. Okay, but that's a template for your periodic table. And when we were going through all these quantum numbers, principal, angular, magnetic, I told y'all the principal quantum number, that's what's written right here down the side of the periodic table. Right? That's N. So you know, like if I said strontium. Well, look where strontium is. Strontium's number 38. Its highest principal quantum number for strontium is a 5. Okay? And we can see that. Now, the angular momentum quantum number, the next one, that's why that periodic table y'all are looking at, that's the different colors. Groups 1 and 2, that corresponds to L equals 0 or S. Do y'all see that on the sheet? And that one in your books actually got it broken down to 1S, 2S, 3S, 4S, 5S, 6S, etc. Y'all follow that? That's L equals 0. Where is L equals 1? It's over here. L equals 1. Everything over there is a P. And you can see that there's no 1P, right? You look at that sheet, there is no 1P. Here's 2P, 3P, 4P, etc., etc., etc. So those are the P's, and that's L is equal to 1. The transition metals here, that's where L equals 2, and that's the D's. If you look closely at the D's, that's the blue ones on your sheet, on your page. Even though scandium through zinc, y'all see numbers 21 through 30, even though they're in the 4th period, right? Look at how it's numbered on there. It's not numbered 4D. Do y'all see that this is a 3D and then a 4D? Those drop down. So even though when we look at the periodic table it looks like 4D, it's not. You got to go down one. 3D, then 4D. You follow? This stuff down here at the bottom, that's what's inserted there in yours in yellow. And the reason it's there is because look at the numbers, 56, 57, 58. So they insert it so that the atomic numbers are correct. These are your F's down here at the bottom. And on your periodic table there in your book, as I was saying, they're inserted right here because that's where they go along with atomic number. I will not go into these F's on anything I ask you on the test. Okay? So you won't have to go that far. That might not mean a lot to you right now, but it will. So what is all this 1s and 2s stuff? These are orbitals. And y'all, electrons fill the orbitals. So if electrons fill the orbitals in order from lowest to highest energy, what is the lowest energy? 1s is the lowest energy. Next comes 2s. Then comes 2p. Then comes 3s. Does anybody know the order? I don't want you to guess, but does anybody know what I'm doing? You know? Do you know what comes next? 3p. 4s. 3d. 4p. 5S, 4D, I ran out of room. On top of 4D comes 5P, etc. That's the order. And you have to know the order. How are you going to know that order? Exactly. Let me show you. There's different ways to know the order. What I like to do, guys, how do y'all read a book? How do you read anything? Left to right. One line at a time, right? If you go back to that periodic table that you're looking at there, the one I've got drawn up here, if I start at the top left and I read it one line at a time, left to right, the first line I read is 1S, right? That's the lowest energy. Then I go to 2S, 2P. Then I go to 3S, 3P. Then I go to 4S, 3D, 4P, 5S, 4D, 5P, 6S, and that's where I would stop.